Hello. Today we're going to be graphing a piecewise function, and we have three different functions. We have a linear function, we have an absolute value function, and we have a radical function. All right, first, before we get started, we're going to graph these, but before we get started, I'm going to show you on Desmos what the three functions graphed together looks like. So on Desmos, I have the three equations entered in. So here's our first equation. This is our linear equation. And the restriction is already applied. Remember, our restriction, the interval for this is when x is strictly greater than or equal to -2. Here's our red line indicating that linear equation. Our second equation, which is an absolute value. So remember, absolute value functions give us a V-shaped graph. And we have this -2, which represents the negative represents it's going to reflect over the x-axis. In other words, it's going to be facing downward. And our restriction is between -2 and 1. That's our interval. And for our third function, that's our radical function. And here it is. That's our green function right here with the vertex at 1, 3. And our interval is greater than 1, greater than or equal to 1. All right, so now we're going to graph it on paper to see how this looks. All right, so here we go. So we're going to graph our three functions with these intervals. So basically, we're going to graph our three piecewise functions. First we're going to start out with our first restriction, which is x is less than or equal to -2. So we're going to go and find where x is -2, which is here, and we're going to draw a dotted line going up and down where x is equal to -2. All right, and we're going to graph our first equation, which is a linear equation. So remember, this is our y is equal to mx plus b. You always plot your b first, which is your y-intercept. So let me change colors here. So my y-intercept is at 3. And then I'm going to go down 1 and then to the left 4. So 1, 2, 3, 4. Down 1 to the left 4. 1, 2, 3. And then a little bit off my graph. Notice that I didn't make a big dot on anything greater than -2. Because that's not included in our function. So we're going to come over here. We're going to connect our dots. So we're going to start off with where the dotted line is and go downwards. Put one arrow here. Because essentially our linear equation does not exist where it's greater than -2. It strictly exists when it's less than or equal to -2. So we only have this portion, this piece of it. Graphing our second function, which is our absolute value, let's go ahead and make a note of our intervals. And our interval for this function is between -2 and 1. But this time, take note, there's no equal sign. So when we graph this absolute value function, if it falls on these two numbers, they have to be an open circle. All right, so between -2 and 1. And since our -2 is already on here, here is our 1 when x is equal to 1. We're going to start off with our vertex, and over here off to the right, I'm going to go ahead and make a quick table of what this looks like. My vertex is -1 and 2. So at -1 for the x, and +2 for the y, there's my first point. All right, so let's pick another point here. Since it's a V shape, it's going to have symmetry, so we could definitely pick 0. If I plug in 0 into my equation, that's 0 plus 1, which is 1. Absolute value of 1 is still 1. Times -2, that's -2. Plus 2, that gives me 0. So at 0, 0, here I am. It's included. Another point that we could pick, let's pick +1. 1 plus 1 is 2. Absolute value of 2 is still 2. Times -2, that's -4. Plus 2, I'm at -2. So at 1 and -2, this is an open bubble because it lands right on our dotted line. And remember, if it lands on this, for this particular interval, there's no equal sign. So therefore, it's not going to be included. Likewise, if we use symmetry, because we know this is our V shape and it goes here, stops there, so it's in between these two. If we use symmetry, then the other point would have to be here, and it's open because again it lands on that line. But if you want to double check this, this is at -2, so let's just double check to see if we're right. -2 plus 1 is -1. Absolute value of a -1 is +1 times -2. -2 plus 2 is 0. So there we go. So that is our function, our graph for the absolute value. Now moving on to the radical equation. Once again, we could do this again with a little chart. I'm going to make my little chart right below it. Start with the vertex. My vertex is at +1 and 3. The condition is it has to be greater than or equal to 1. So if it happens to land on the dotted line, for this particular case, we can close. It's going to be a closed circle because it's got the equal sign. All right, so at 1, 3, let's graph 1, 3. So at 1, 3, we are right here. All right. It's a radical function, so we know it's going to have that curve because it's basically half of a parabola. So a point higher than 1, well, that's 2. Plug that in. 2 minus 1 is 1. Square root of 1 is 1. Plus 3 gives us 4. So at 2, we're up 4. So 1, 2, 3, 4. And then one more point, let's see, 5. Let's pick 5, because 5 minus 1 is 4. Square root of 4 is 2. 2 plus 3 is 5. So 2, 3, 4, 5, up 5, 1, 2, 3, 4, 5. Let's curve this nicely, and we know it's going to go in this direction. All right, so we are done graphing it. It all falls into the intervals that was given to us. Now we're going to go ahead and answer the questions right below it. At the function f of -2, you could just go directly to your graph. Find when x is -2, and it's here. Do not include the points that are open. That means they're not included. So you're going to have to go up, and it actually falls into that point. So that is at 2.5. 2.5 on the y-axis. All right, when it's 0, when x is 0, we're here. So that means y is 0 as well. When x is 1, we cannot include the open bubble, so we have to go the other direction. This one's included, so that is 3. So when x is 1, y is 3. The domain for this function, because it goes forever in the left and it goes forever in the right direction, and everything in the middle is included, we call this all real numbers. We could also think of it as from -infinity to +infinity. Okay, now let's look at the range with the same idea, but now we're looking for the y. And if we notice here, we notice that we're kind of like semi-stopped at the -2 because of the absolute value, but realize that this linear equation keeps going lower and lower and lower. So therefore, our range is also going to fall under all real numbers, which goes from what you could think of it as -infinity to +infinity. All right, and that concludes our video of graphing piecewise functions.